we will discuss about the response of one first order system for impulse type and step type signals. So how the mathematical formulation is used to get the output of a first order system, right? So this is say your one first order system, and this is your CS and this is your RS. Now we have to find out this when this RS is either impulse or step, right? So consider one kind of first order system, like the system structure is, say, this is 1 by st. This is your open loop transfer function, this is your CS, and say this is 1. That means Hs is equal to 1. So this is unity feedback system. Now if you make the closed loop, as we have already discussed, that we have to find out the response when particular type of input is applied to it, and in that case you have to get the characteristic equation. That means you have to get the closed loop transfer function. So closed loop transfer function corresponding to this CS by RS, you get 1 by st by 1 by 1 by st into 1, gs by 1 plus gs into hs. So hs is equal to 1. So you get from this 1 by 1 plus st, right? So from the denominator part, you see what is this. If you can express this in terms of s plus something, what happens? This is your t. So you see this is t of s plus 1 by t. That is 1 by t in the numerator divided by s plus 1 by t. So this is a first order system. Now as this is a first order system, and this, what is this t? T is some constant, whatever may be the value of it, and normally this is known as time constant. This constant related to the system, any type of system, first order, second order, type 0, type 1, this type of constant is known as time constant. And what is the function of the time constant? That in later on, step by step, you will full understand this. So we have to find out the output. That means CS you get equal to 1 by t by s plus 1 by t into RS, right? So first of all, I'm going to discuss about the impulse response, right? So first of all, this is the standard form of output signal. That is, from here you can get the output, that is the response for a particular type of input. Now impulse response, what does it mean? Impulse response means if the input is impulse, this is your output, right? Impulse response. So impulse response means if RS is equal to impulse, then CS is your response. So overall, this is called the impulse response. So that we can obtain from this expression, right? Now everything in nature already I have discussed in continuous time function. So impulse, the definition of impulse is that in that case, what is the input? Input is RT. RT is equal to delta t. That means 1 for t is equal to 0, 0 otherwise. For any value of t is equal to 0, other than 0, you will get the value of this input signal is equal to 0 for impulse. This is your type of impulse signal. You are applying this signal. This is your input. This is your input signal. This is your amplitude. This is time t. This is t is equal to 0. Fine. So if this is your RT, then RS is equal to 1. If you get the Laplace transform of RS, you get RT, you get RS is equal to 1. If you get RS is equal to 1 from this expression, what is the value of CS? CS will be equal to 1 by t by s plus 1 by t into 1, right? So you have to find out the response, that means output signal, in terms of time, Ct. So Ct is your desired value, that is equal to Laplace inverse of Cs. So Laplace inverse of 1 by t by s plus 1 by t, right? So if you get the Laplace inverse of 1 by t s plus 1 plus s plus 1 by t, so what will be the output Ct, right? So that is a basic knowledge of Laplace transform, and inverse Laplace transform will give you the answer, right? For next we will get the Laplace inverse of it and get the Ct. Ct is equal to, we get Laplace inverse of 1 by t plus 1 by t. You see, this is s plus a, and standard form of 1 by s plus a is equal to e to the power minus at. This is the standard form of Laplace inverse. So you get Ct equal to 1 by t e to the power, t is 1 by t, sorry, a is 1 by t. So you get e to the power minus t by t, right? So what you actually obtain is Ct is equal to e to the power minus t by t. So this is the expression for the response. Now how can you get the graphical representation of the output? This is your time, t is equal to 0. This is your amplitude. Now at t is equal to 0, put the value at t is equal to 0. What you will get at t is equal to 0? You see, small t is equal to 0, that means Ct, that means C0. At t is equal to 0, output C0 is equal to 1 by t, right? So 1 by t. Say for depending upon the value of t, if the t is say 2, so C0 is equal to 1 by t. If t is equal to 4, then this will be 1 by 4, that means 0.25, and so on. So at t is equal to 0, you see there is a value 1 by t. Now at t is equal to say 1 or positive infinity, you see, positive infinity means e to the power minus infinity, that means 1 by e to the power infinity, that means 1 by infinity. So this will give you 0. So t positive infinity, Ct equal to 0. Again t is equal to minus infinity, you see this value is again 0. Ct equal to 0. That means this value of this is like this, and when you will go to this direction, the Ct, this is your Ct curve versus t, so this will be 0. Now as you see, e to the power minus t by t, this is some constant. So e to the power minus t is an exponential decay curve. So this is like this. Similarly, this is the impulse response. So actually this is the impulse response where 1 by t is the value at t is equal to 0. So that is the mathematical formulation. That means how can you get the output for a particular input when applied. So that is known as the response. So that is how the impulse response of a first order system is obtained. Now by the similar procedure, I will show how to get the step response for a first order system. So next part, step response of first order. Now you get Cs by Rs already obtained for a first order system, that is your 1 by t by s plus 1 by t. Now in order to get the step response, this Rs, that means your input, your input will be 1 for t greater than is equal to 0, 0 otherwise. That means the input signal is like this. This is your time, this is amplitude, this is 1. So if you get the Laplace transform of it, Laplace of Rs at t is equal to 1 by s. Already we have developed this in the previous lectures. So this is your Rs. Just put this value there and you get CS output is equal to 1 by S into 1 plus TS. I am just multiplying these terms and get back this 1 by 1 plus TS, and CS RS is equal to 1 by S. So it get simplification of it, you will get 1 by S into 1 plus TS, right? So this is your CS. Now what you have to do, you have to get the CT. That means again you have to get the Laplace inverse of it. That means Laplace inverse of 1 by S into 1 plus TS. Right. So how to get it? You see, this is S into 1 plus TS. That means this is two factors are there in the denominator, and simplification of it by using the partial fraction expansion. I will show you how to get the partial fraction expansion of it. So this is your, say, A by, in order to get Laplace inverse, so first of all what to do, you have to get the function as 1 plus TS. That is equal to, you may write, there are two factors in the denominator, S and 1 plus TS. So you can write A by S plus B by 1 plus TS, right? So A and B are known as residues. So we have to calculate the residues. How to get the residues? To get the residue A, see, in order to get the residue A, what you have to do? You have to multiply the denominator of that function A is into your left hand side complete term, that is 1 by S into 1 plus TS. And what will be the actual value of A? So in that case you have to put some value of S. That means when you solve this, that means in the denominator you solve the value of S, what will you get? You solve the denominator value of S, that means here you get S is equal to 0. So put at S is equal to 0. That means after getting the simplification of it, what will you get? You will get 1 by 1 plus TS, and you have to put the value of at S is equal to 0. That means what you will get? You will get, put the value of S is equal to 0 here, that means 1. So the value of A is equal to 1 by this formula. Similarly, how to get the value of B? Similarly, how to get the value of B? That means we have to take the factor in the denominator of the B, and that factor is multiplied with the left hand side function. Then from this, you see 1 plus TS. From 1 plus TS, you have to find out the value of S, and you have to calculate the complete term with respect to that. That I am going to show you. How to get the value of B? The procedure is that you have to multiply 1 by S, 1 plus ST into the complete left hand side function. That means 1 by S into 1 plus ST, and that is to be calculated at the value of S is equal to, what is the value of S? 1 plus ST equal to 0. That is your this function. That means this function. So S is equal to minus 1 by T. So at S is equal to minus 1 by T, right? So this will become this, and 1 by S at S is equal to minus 1 by T. So what will get? Minus of T. So the value of B will be equal to minus of T, right? So you get the value of A and B. Once you get the value of A and B, the total function will be like, in that case, of L inverse is 1 plus ST will be equal to A. A means 1 by S plus B. B means minus T by 1 plus ST. That is, you can write minus T by 1 plus ST, right? So what is this? This is actually your CS, right? So now you get the value of CS, and if you get the Laplace inverse of CS, you get CT equal to Laplace inverse of 1 by S minus Laplace inverse of t by 1 plus st, right? So you can just write like 1 by s minus L inverse of, see, divide this numerator and denominator by t. What will you get? 1 by this t divided by t. That means if you get, or in other word you can do it, t s plus 1 by t, you can do it also, right? So t will be automatically cancelled out. You get 1 by s minus less inverse of 1 by s plus 1 by t, right? So what is the factor? L inverse 1 by s. You know, L inverse 1 by s means 1 from the function of Laplace transform. And Laplace transform of 1 by s plus a, already in the previous part when we are discussing about the impulse response, we have found out what is that. That is e to the power minus t by t. So this is your ct. See, so ct, that is the response for a first order system when subjected to some step signal. So ct is equal to 1 minus e to the power minus t by t. Now I am going to just get the curve, how the ct is looking like, and from that you will be sure that how the output is following the input. So what we get? We get this ct is equal to 1 minus e to the power minus t by t. Now this is your output, and now if I draw the graph, this is your time, this is your amplitude, and see, as we are dealing with the step response, so this is 1 and this is your input, right? So output should be like this, or output should follow the input. Now what happens at t is equal to 0? See what happens at t is equal to 0. That means from this expression you get ct at t is equal to 0. What is this? 1 minus e to the power minus 0. That means 1 minus 1, that is 0. So at t is equal to 0, the value of the output is 0 here. And you see, we are only considering this part. If you consider only t by t, t is some constant, so t 0 to infinite, that means 0 to infinite. If you vary the value of t, what you get? This is exponential decaying curve as e to the power minus t by t. So it is an exponential decaying curve. And you see, only if you consider only this part at t is equal to 0, e to the power minus t by t equal to 1, right? That means for this curve only, it will be starting from this position, that means from this. So at t is equal to 0, the value of e to the power minus t by t is equal to 1, and this is exponential decaying curve like this. This is exponential decaying curve, and ultimately what we have to get? We have to get 1 minus this curve. So 1 is this is input, and this is basically e to the power minus t by t curve, right? So the difference between these two, if you observe, at t is equal to 0, what is the difference? 0, because this is 1 and e to the power minus t by t, this value is also 1. So at t is equal to 0, the difference is 0. So this is your 0. Now as the value of t increasing, so the value of this input signal remains same, and e to the power minus t by t is decreasing. So 1 minus this value will be increasing in the similar fashion, or the just reciprocal of this part. So 1 minus e to the power t minus t will be like this, right? So this curve means 1 minus e to the power minus t by t, which is actually your ct. So this curve is your output curve, right? Now how and what is the conclusion from this part we can draw is that, see, initially when the system is switched on, so output curve is not exactly the input curve. After certain time, see, this is the time t. after certain interval of time, this curve is gradually reaching the input. That means it is trying to follow the input. So that is your control objective, that output should follow the input. So output is following like this, and after certain time you see this output and input are actually in the same line. You see the green line and this you see this orange line. So there is no difference between these two. So this part is known as the steady state region, and where the error actually, this is your error equal to 0, right? So that can be obtained mathematically, because this is the graphical way how the output is approaching input and at the steady state value when t tends to infinity. At steady state value means what? Steady state value already we have discussed at t tends to infinity. So t tends to infinity, what is the value of it? You see, t tends to infinity. So t tends to infinity, steady state error. Sorry, this is not the value, this will be error. So error means E of t, right? E of t. What is the E of t? E of t means RT minus CT. This is your error. So what is the value of RT here? RT is equal to 1. What is the value of CT here? 1 minus this. That means minus 1 plus e to the power minus t by t. So what is the error we have already obtained? Et equal to e to the power minus t by t. You see, when we call about the error at steady state, what we will have to do? T tends to infinity. That means limit t tends to infinity et. This is your steady state error, ESS. So that is equal to, you put the value of t is equal to infinity here, 1 by infinity, that means you will get the 0, right? So mathematically what we obtain, we have obtained that at t tends to infinity, the error is 0. Error is 0 means there is no difference between the input and output. So output must reach exactly the input. So error becomes 0. And steady state error for the first order system when subjected to unit step signal is always 0. So that is the characteristics and response characteristics and how to get it for the first order system.